Hi, my name is Tommy. This is for recording my Python carving program. So mainly for this program, I developed by myself that there are two inputs are there. One is that scaling. Scaling means suppose if it is above 1, that means the image is enlarged image. If it is below 1, that is means it's small image. So if it is scale dot 0.5 means it's it is half the size, reducing the half the size of the image. So right now for example I'm using fig 8 as an image. So I'm passing this fig 8 as an image. So what's going to happen, it's looking for the seam. So here I'm passing three arguments. One is that image, the input image, scale, and third one is that image 1. That image 1 mainly uses for seams, so it one shows all the seams. So I'm just showing some examples before running this program. So here, so whenever I'm calling this find seam, it's going here, this find seam. If it is below, right, currently it is below 1, that means that is for seam removal. So it is looking for look column, that is for carving. So it's going for look column here. So this look column having image and image 1, two arguments. So this image 1, first it need to find out the minimum energy path. So once it get the minimum, to get that minimum energy path, we are using Sobel algorithm. That means that algorithm is calculating, derivatives of x and y based on some calculations. So derivative here, energy is calculating based on the Sobel formula, and after that once it's implemented, we are getting the minimum seam minimum. So from here we are using a array called backtrack. This backtrack is having the minimum energy path. So here we are whenever the first run, we are getting the minimum energy path. Once you got the minimum energy, we are the scaling start to run. The next time the scaling run, then finally we are getting the output. I'm just showing how to run the program because we have only limited time. Look, this one is running. So after running this one, I can show you the output here. The output would be in my C drive, Georgia Tech, empty. Right now you can see some output, some changes here.